Hello, viewer. And in this virtual class, we're going to solve this quadratic equation before us using the Po-Shen Low method and also the completing the square method, to resolve this question. And the question before us is 5k squared minus 4k minus 5 is equals to 0. So we're going to use the tool approach, an approach adopted by Professor Po-Shen Low, and the completing the square that we're used to. Okay, the Po-Shen Low approach stipulate that once you are given a quadratic equation, it is possible, to obtain the root if we are able to know the distance where the curve touches the x-axis. So we know the distance there, and also look at the average of the sum of the roots. So let's go quickly into what we're supposed to do. Here, this is what we do here. One of the roots on the left hand side will be minus z minus b over 2a, and the other root will be z minus b all over 2a. Okay, and our the formula for z is the square root of b square minus 4ac all over 2a. This is the formula for z. We have proved it in our previous class. All we need to do here now first is to look for what is a. A here is 5, and b is minus 4, and c is equal to minus 5. So first, let's look for the average of the roots, which is minus b over 2a. So we have known that b is minus 4, so we have a minus, open bracket, minus 4 all over 2 times a, which is 2 times 5, and minus times minus is plus. So here we're going to have 2 over 5. That is the value of the numerical value of minus b over 2a is 2 over 5. Next, let's find the value of z. So here we said z as its own algebraic expression, the square root of b squared minus 4 squared, that will give us 16, minus 4 times a is 5, times c is minus 5, all over 2 times a, which is 5. So if we do this, minus 5, minus 4 times 5 is minus 20, minus 20 times 5, that will give us 100. So that will give us a square root of 116 over 10. Okay, this is 16 minus 4ac. 4ac. 5 times 5 is 25. 25 times 4 is 100, plus this 16, that will give us 116. That's the value of z. Okay, now for us to obtain the value of one of the roots here, the one that has negative, what we need to do, we just multiply this by minus z. Okay, minus z. Okay, let's see whether if 4 can divide 116. 116, can 4 divide it? 4 in 11 is 2. 4 in 11 is 2, remainder. Okay, it gives us yes. So here, this expression, we will reduce it. This will become root 4 times root 29. 29, 4 times 29 will give us 116 all over 10. So that this is root 4 is 2. So that here the value of z will becomes root 29. Root 29 over 5. Because 4, square root of 4 is 2. 2 here 1, 2 here 5. So the value of z is root 29 over 5. Okay, that is the value of z. So for us to get this root, this is one of the roots. So we multiply z by minus 1. So one of the root will become, if we multiply z by minus 1 here, one of the root will become minus root 29 over 5, and the value of minus b over 2a is this, so this becomes plus 2 over 5. Then the other root, for us to obtain it, is just z, and z is root of 29 over 5, and the value of minus b over 2a is plus 2 over 5. So the value of k here, value of k, this is k, the 2 value of k, 1 will become 2 minus root 29 all over 5, and the other value will be 2 plus root 29 all over 5. These are the root of this equation. Okay, now we have used the Po-Shen Low approach. Now let's use the completing the square method to see if our workings is absolutely correct. From this equation given here, we have a 5k squared minus 4k minus 5 is equal to 0. In the completing the square, I said the first thing you do, you must look at the coefficient of the highest power here, which is 2. Okay, the highest power of the unknown here is 2. So you look at the coefficient of the highest power of the unknown here, which is k, the unknown is k, you divide it through by that coefficient. So the coefficient of k squared here is 5. So we divide through by 5, by 5, by 5, by 5, through and by 5. So here will be reduced to k squared minus 4 over 5k minus 1. 5 divided by 5 is 1. So the right hand side is 0. 0 divided by 5 is 0. Okay, the next step is that we look at this constants here that does not contain the unknown. We move it to the right hand side. Here is minus 1. So this is minus, as it crosses to the other side, it becomes positive. So here we say this is k squared minus 4 over 5 k is equal to 0 plus 1, and eventually becomes 1. That's the step 2. We ensure that the constant term is moved to the right hand side. So the next step is that you have to be careful here. We are going to look at the coefficient of k here. The coefficient of k. The coefficient of k is minus 4 over 5. We're going to look for half of it. That is times half. Okay, this here is 2 here 1, 2 here 2. So we're going to be minus 2 over 5. Having obtained this, the half coefficient, the next thing is to square it. So this term here, you add it to both sides of the equation. You add it to the right hand side and the left hand side. So this become k squared minus 4k over 5 plus open bracket minus 2 over 5 all square is equal to open bracket minus 2 over 5 all square plus 1. So we have done that. We have added it, the half coefficient of k squared, to both sides. And once you come to this place, all you need to do here is you pick just what you have here and pick the unknown here. The unknown is k. The unknown in this expression, what we are looking for is k. So you pick k here. And what is in this bracket? Ignore the square. Minus 2 over 5. So minus 2 over 5 in this form, and you put a square here. Okay, now what this simply means is that by the time you expand this k minus 2 all square, it's going to give you everything. It's going to give you k squared minus 4k over 5 plus, when we square this one, definitely is going to give us 4 over 25. So that is the implication here. The next step here is that you look at the right answer. If you square minus 2 will give us 4, square 5 will give us 25 plus 1. Okay, in order for us to move forward, here this is a fraction already. And how do we handle the right hand side? Here, this is the right LCM. We put LCM here, which is 25. 25 divided 25 is 1. 1 times 4 is 4 plus. 25 divided 1 is 25. 25 times 1 is what? Is 25. So here, we come here, this become k minus 2 over 5. Close your bracket and you square it. The open bracket, k minus 2 over 5 all square. And here, we have a k minus 2 over 5. Okay, the next thing here we need to do here is that we need to get rid of this square here. And what do we need to do? We say we take the square root of both sides. Take the square root of both sides. Take square root of both sides. Once you have done with that, because it is a quadratic equation that it is necessary you're going to have a two pair of equation, because in your graph, so these are assuming this is z, this is minus z, we are going to have two pair of equation. That is where the curve touches the x-axis. So here is going to be plus or minus the square root of 4 plus 25 is 29 all over 25. Okay, here we have a k. This is minus 2 over 5. Is going to cross to this other side because we are looking for just k. The two possible value of k. This become 2 over 5 plus or minus the root of 29. There's no complete root in form of whole number, so we leave it like that. All over the square root of 25 is 5. So that k is equals to 2 plus root 29 over 5, or 2 minus root 29 all over 5. So you can see that the roots are not different, using both the Po-Shen Low and the completing the square. Our results are the same. Okay, please, all you help me do, help me subscribe and also share to other platforms. Have a nice time. See you in my next virtual class.